So the problem that we're going to be looking at is part C. And in part C, we're given all the sides of the triangle. So I don't have to draw this triangle to know that this is going to be a side, side, side triangle because, well, I'm just given all the sides already. So I'm going to label this as side, side, side triangle. And I have to find the area of this triangle. Now, to do that, I can't use that first formula I was using like I did before. So the area formula for oblique triangles, the one that has signs in them. I don't want to use this formula because I'm not given an angle, so I'm not going to bother to use this formula. Instead, I need to use Heron's formula. So in order to use Heron's formula, I actually have to first calculate the semi-perimeter. And what that is adding up all the sides and then just multiplying it by half. So I'm going to do that first and figure out what that number is. So let me zoom in there, that's better. So my semi-perimeter is 1/2 times A plus B plus C. So this would be my A, which is 25 plus 35 plus C, which is 32. If I add them up and multiply by a half, I get 46. So like I said before in the other video, when you're typing a half in the calculator, just do 0.5 and then multiply it by this here. So what I did was added these numbers up and then multiplied it by a half, and that's how I got 46. Once you get your semi-perimeter, you're going to need to use this number in the area formula. So I'm just going to write the area formula real quick so that way you guys can see it. So up above or in the first page, the area formula is always S, the semi-perimeter, times S minus A, times S minus B, times S minus C. Okay, so in this case, I'm just reusing S several times. So this is going to be 46 times 46 minus A, which is 25, 46 minus B, which is 35, and 46 minus 32. And so you can plug this in the calculator in one go. I just don't always recommend that because you could make a little tiny error if you forget a parenthesis. So I'm going to go ahead and subtract the inside of the parentheses first, just to make it look a little bit cleaner. So 46 minus 25 is 21. 46 minus 35 is 11. And 46 minus 32 gives me 14. So that might help us clean up a few things. So I can just go ahead and multiply this all together. And that would give me 148,764. And then just take the square root of that number. So if I take the square root of this number, I get 385.699 if I round to 3 decimal places. By the way, I want to mention, you can plug in all of this in one go, perfectly fine. But I think as a beginner, if you're not very good with the calculator, just do it step by step and then take the square root later. But I believe a TI-84 calculator can handle that type of order of operation. All right, so I'm going to write my answer here. So this is going to be 385.699 as my area. And I'm done. So Heron's formula is a little bit longer, but it's really not that bad, especially compared to what we were doing the last few days. So you just have to find the semi-perimeter first. That number you're going to be using in the area formula in Heron's formula, and then you'll get to the area value. So this one looks like another Heron's formula because you're given all 3 sides. So again, this is another SSS, triple S triangle, and we got to find the area, so we have to start by finding the semi-perimeter. So the semi-perimeter is always half times all the sides added up, or the sum of the sides. So if I just take all of these numbers and add them and multiply by a half, I get, I think, a decimal number this time. So 18.5 is my S value, or my semi-perimeter. So now I'm just going to plug it into the area formula. So that's going to be S times S minus A, S minus B, and S minus C. So if you need to rewrite the formula just to practice with it, you're more than welcome to. Once you get good at this, you kind of have it memorized. So S is 18.5. 18.5 minus A, which is 12. 18.5 minus 17, which is B. And 18.5 minus C, which is 8. All right. I'm just going to take it nice and slow and subtract everything that's inside the parentheses first before I multiply. Just like to try to stay consistent. So if I subtract, this is going to be 6.5 when I take 18.5 and subtract it by 12. If I subtract it by 17, I get 1.5. And if I subtract it by 8 here, I get 10.5. All right, I'm going to go ahead and just take the square root and multiply all these four numbers together. And if I round, I get 43.519 as my area. So about 43.5919 for the area. I'll write that to the side. And that's it. So pretty simple here, just using the formula. You just need to know which formula to use depending on your situation. So if you have all three sides, use Heron's formula. If you have one of the angles and two of the sides, then you probably want to use the oblique triangle formula. Let's do a story problem here. So this one is about a parking lot. And it says, the parking lot has a shape of a parallelogram. So back in your geometry class, you might have learned that a parallelogram is kind of like a rectangle, but tilted. So at an angle. So it still has four sides. And the length of the two adjacent sides are 70 meters and 100 meters. The angle between them is 70 degrees. What is the area of the parking lot? Okay, cool. So here's the thing. Parallelograms, if you want to find the area of a parallelogram, so let's just call it AP, it's base times height. The good news is we have the base. The base is 100. Bad news is we don't have the height. They did not tell us the height of this triangle. We don't know what that is. So I probably don't want to use the parallel area formula just because I don't have enough information. A lot of people will say, well, what is that 70 degrees? Isn't that the height? No, that's not the height. That's just the side of the parallelogram. So it's like the width. So if this was length, this would be the width. It's not the height because height is always directly to the base at a 90-degree angle, which this is definitely not. It's at like a 70-degree angle. So in this case, we need to use something else. And when I look at this picture, I think, oh, maybe I can divide this picture into a triangle. Like if I could think of this as half of a triangle, half this parallelogram as a triangle, then if I find this first half, I can add it with this half and get the full length. So what I'm going to do is find the area of this triangle first. So I'm going to call that AT. And to do that, I have the two sides and an angle. So I'm like, okay, if I have side, angle, side, then I can use the oblique triangle formula, this formula here, because I have two of the sides and then one of the angles between them. So I'll just use that formula, which is going to be 1/2 times the two sides, so 70 times 100 times sine of the angle that's between them. And so I've set things up. I'm going to go ahead and plug this into my calculator. So if I take a half, or 0.5, and multiply it by 70, 100, or sine of 70, I get 3288924. And this is in meters, so I'll have to say this is in meters squared. Okay, cool. So I found the area of the triangle. So all I have to do is multiply this number by 2, because that way I can get this half and this half. So if I want to find the area of the perimeter, it's really just 2 times the area of the triangle. So I've kind of made my own formula here to help me out by using trigonometry, a little bit of it. So I'm just going to take that area that I found earlier for the triangle and pull that in. So if I multiply 2 with this area of the triangle, I get 6577848. And this is going to be meters squared, because our units are going to have to be squared if we're talking about area. All right, and that is it for this problem. It looks like our area of the parking lot is 6,577.848 meters square. All right, that is it for this video. I hope you guys found this helpful. Bye, guys.